Okay, Connor, this one's for you. We're going to see how this goes. So the question was, right now, this ring is set up so that it won't accept this, this sphere through it. And the question we asked the class here, that only Leo got, by the way, is if I heat this ring up, will it get bigger? Will it get smaller? Will it stay the same size? And will I be able to do anything with this? If you want the answer, ask Leo. He's the true only genius that I've ever seen within the Trinity building. Smarter than me, smarter than Grandpappy Botzer, you know, smarter than us all. That's Leo. But seriously, Leo got it right. Nobody else did. Leo's reasoning was also insane, but that's okay. He got it right. So what we're going to do is we're going to try not to burn the school down here, Connor, and you're probably like over in this camera because you're a different camera. And I got this blowtorch here. There's not a lot of gas in it, so we'll see how this goes. But here goes nothing. They tell us... Oh, that went away. Not cool. Normally I get one of you students to sacrifice yourselves and hold something for me, but okay. It's COVID. I can't do that. I legally can't do that.
Wait, what if? What are you gonna do with that? Like, put it on the stick.
Okay, torch is going. I want to see this sucker up. This is the fun part. How you doing? The tip of the blue is the hottest part of the flame. We're just heating this up. We're going to do our best not to touch it. As this is heated up, hopefully everything works properly. And the ring got bigger. Now the real key is not to let it cool down when it's out here. I won't be able to pull it back through, but if I do that, I can't even blow on it to cool it down. But I leave it like this, it will get stuck. So yeah, it went through this time. So the ring did get bigger. I'm not completely crazy. Neither is Leo. He got that. So when you heat this up, it does indeed expand the ring, allowing... Oh, there it is, it's stuck. I just got it stuck. Yeah, that's the other issue. Now I'm going to expand the sphere inside of it. We're going to just set that in the sink for now. I'll take care of that one later. The other thing I've got up here, this is a very fascinating thing. It's just a strip of metal, or so it looks. But when you heat it up, it looks like it's just warping. But that's not what's happening. This metal isn't warping. This metal is expanding. This metal is undergoing a linear expansion. Except, I keep saying this metal, and what I should be saying are these metals. This is a bimetallic rod. The rod is actually made up of two different metals here. These two different metals have different coefficients of linear expansion, which we'll talk about in a future video. Because they've got different coefficients of expansion, one side of this as we turn off the death torch, there we go. Because they have two different coefficients of linear expansion, one side of this metal is actually going to expand more than the other. And since they're bound together, they're going to bend. This outside here, it's on the longer path. Imagine you're running around the track outside. This is the longer path here. This is the greater coefficient of expansion. It became a longer piece of metal. Metal on the inside, it still expanded, but it expanded by a lesser amount. So it bent this way. It's an important thing. There's actually two metals here for this bimetallic rod, and that's what we're kind of looking at here. So hopefully this was interesting. Hopefully you see this, Connor, and hopefully I fix this. We'll see. But until next time, adios, and take it easy.